Number 4. So number 4 is the stoichiometry question. Okay, we did stoichiometry in Unit 6. The difference was we did mass-to-mass stoichiometry. In both cases, you have to have a balanced equation. In both cases, you have to have a molar ratio. The difference is that we're converting to moles with a different system. Okay? But the dimensional analysis is the same, and the concept behind the setups are the same. Okay? As I said in number 2, what you pick in this problem is the amount that for which you know the concentration. That's what your starting is. Okay? Ryan? So in number 4 then, we're going to pick the amount for which we know the concentration. That's 20 milliliters. Because we know that the concentration is 0.200 molar. Okay? So we're going to put the 20.00 milliliters of the KOH solution on the top. Okay? That's what we start with. Since I'm doing molar calculations here, I need to have this unit of measurement in liters. That's what molar is. It's in moles per liter. So I need to have this in liters too. You have a question?
Is the first number always going to be the first one on top?
Not necessarily, but usually that's the way it's written. Not always written that way. If you remember that phrase for number 2 and number 4, those kind of questions, if you remember, the starting amount is the amount for which you know a concentration. That tells you which one, huh? Concentration is molar. Milliliters is an amount. All you got to do, you got to find the measurement, the amount of which you know a concentration. Okay. So to get from milliliters to liters, I need an equality statement. What's the equality statement that defines the relationship between milliliters and liters? 1,000 milliliters equals 1 liter. Okay. Where do I want to put the milliliters? On the bottom. Okay. That allows us to cancel the milliliters. Okay. This is becoming a problem. It became a problem a long time ago.
Why are you just looking at me?
Let's not let it be a problem anymore.
Why are you looking at me?
Because you're part of the problem.
I can laugh.
You can't distract my class.
Okay, go.
All right. So now we have liters of KOH solution, and we can use the concentration to convert to moles. So if we use that 0.200 molar concentration, writing it as a fraction, where we have moles KOH over 1 liter of that KOH solution. I cancel everything but moles. Once I have moles, now I'm ready to go from one species to another. That's where I need a balanced equation. Okay? Balanced equations we first started learning to do in Unit 5. So we have KOH and we have hydrochloric acid, and they're reacting together. So here's KOH, and we need to know the formula for hydrochloric acid. Okay, so this is the question you were asking a while ago about, Mac. I've got an ic ending now and a hydro prefix. Before I had an ic ending but no hydro prefix, so I needed a sulfate ion. Now I've got an ic ending with a hydro prefix, I need a chloride ion. That's a chlorine with a negative charge. Yeah. Alright, so we've got a negative charge here on a chloride. There's the negative charge that goes with it. Hydrogens have to have a plus charge for an acid, H plus, and a chloride has a 1 negative. That's 1 plus and 1 negative. That's a 1-to-1 ratio. The question says that both of these are solutions, so we can go ahead and say they're aqueous. We need to figure out what's going to go on the other side. What kind of equation are we going to have here? Double replacement. Front has to go with the back of that. Front has to go with the back of this, and that HOH here is a polyatomic ion, so we got HOH.
KCl stays the same, doesn't it?
You mean what, in terms of this balancing it?
Yeah.
It does. I was going to show you how to do that. You should know that's water and it's a liquid. Potassium on the periodic table has a 1 plus charge. So this particular one balances out just like our acid did. We have one of each. And we need to know its physical state. And the solubility rules tell us that anything that is a group 1 salt, potassium's in group 1,
Why do you have
is soluble.
Why do you have H plus Cl?
Because I was showing you how to balance hydrochloric acid. Okay? Now we need to balance the equation. It's a really simple one. It really is already balanced, but I want you to show me that. Alright, because it's balanced, the molar ratio is going to be a 1-to-1 ratio, yes.
If we did the bottom versus the matter,
Say what?
if we did all that bottom versus the first,
No, it doesn't matter what order you do it in. That's fine. Okay? Alright. You know what?
I turn it around.
Michael, do you need to step outside to get control of yourself? Alright, so we need a 1-to-1 ratio. 1 mole. In this balanced equation, there's 1 mole of KOH. That goes in the bottom. We need 1 mole of HCl on the top.
You go by working the equation.
Well, that's the molar ratio, this molar ratio here.
That's what I'm saying, but you
Yeah.
go by how many's in the equation.
Exactly. That's why we need an equation, because you've got to go. Anytime you have to go from one species to another, you have to have a balanced equation. From the balanced equation, you build a molar ratio. All right. Recall then molarity, which is what we're trying to find. Molar concentration of the acid is in moles of solute, liters of solution. We have moles of the solute. We've got to get liters of solution on the bottom. We don't have liters of the solution, but we do have milliliters of it. So I can put that on the bottom. Okay, and then convert that to liters. And we already have the equality statement down here. Cancel out the milliliters, and we've got moles of solute over the liters of the solution, which is the question, which is what the question asks you to find.
How many questions on this time?
4.
4.
Yeah.
How many significant digits do I need?
3. 4.
3, because this number right here has 3. See, this leading zero is not significant. The 2 significant, the zeros are significant because they follow both the decimal place and the non-zero digit. Since I've got moles per liter of the solution, I can just write that as capital M with a line under it and say that's an HCl solution. And that's the answer we're looking for. What now? Kind of how the test is going to be,
Yeah,
yeah.
that first part, you good, dog.
Where'd you get 35 mil? Is that in the problem?